Hi everyone, in this video I'm going to solve O-Levels Additional Mathematics Paper 2 in a session October-November 2019 Paper 2-2. So let's start with the first question. Question number 1, on each of the Venn diagram below, shade the region indicated. So the first region is A complement intersection B. This is set A and the A complement is a region that is outside of A and its intersection with the set B. So just this region is shaded. Other than A. Right, and then this section union with A intersection B complement. This is A and its intersection with the B complement. The region outside of B is just this region and the union is just both sections. The union is these two shaded sections. Okay, now A intersection B, this is set A, this is set B, and this is intersection of A and B and its union with the set C. Right, so the shaded region is this, the set C and the intersection of A and B. Right, now for the third part, A intersection B, this is set A and this is set B, and A intersection B is this portion and its intersection with C complement, the region that is outside of C. Only this shaded region, the intersection of A and B other than C. Right, this is a shaded region. Question number 2, given that y equals to 2 sine 3x plus cos 3x, show that d2y by dx square plus dy by dx plus 3y equals to k sine 3x, where k is a constant to be determined. Okay, so first we have to find derivative of y with respect to x. So we have to, the derivative of sine is cos 3x and cos and 3, and cos derivative is minus sine 3x and 3x derivative is just 3. So this is equals to 6 cos 3x minus 3 sine 3x. This is the first derivative, right? Now let me differentiate it one more time. d2y by dx square is 6 is outside, cos derivative is minus sine 3x and 3x derivative is 3, negative 3 is outside, sine derivative is cos 3x and 3x derivative is just 3. Okay, further simplification, 3 times 6 is negative 18 sine 3x and negative 9, 3 times 3 is 9 and cos 3x. Right, now let me substitute this into the equation. So second derivative is negative 18 sine 3x negative 9 cos 3x plus the first derivative is 6 cos 3x minus 3 sine 3x plus 3 times of sine 3 times of y. So 3 times 2 is 6 sine 3x plus 3 cos 3x. Right, now let me simplify this. Okay, so first we have to solve sine 3x, sine 3x, sine 3x and sine 3x. Okay, how many sine 3x? We have minus 18 and with negative 3 and with positive 6. This is minus 15 sine 3x. Okay, now let's solve cos 3x. This is cos 3x and this is cos 3x. So as you can see, 3 cos 3x and 6 cos 3x would be 9 cos 3x and minus 9 cos 3x is just 0. So this is a solution, and from here we can, k is a constant to be determined, so k value equals to, this is k sine 3x. So we can say k equals to minus 15. Question number 3, a 5-digit code is formed using the following characters, letters, numbers, and symbols. No character can be repeated in a code. So no repetition. It's a permutation question. Find the number of possible codes if number 1 there is no restriction. So 5-digit code we have to make. 1, 2, 3, 4, 5. Right. How many possibilities we have? There are 1, 2, 3, 4, 5. 5 letters. 1, 2, 3, 4, 5, 6 numbers, and 1, 2, 3 symbols. So the totals are 6, 7, 8, 9, and 9, 10, 11, 12, 13, 14. So we have 14 options for the first digit of the code, and then we have 13 options, and then 12, and then 11, and then 10. So these are the possible codes when there is no restriction. 14 times, 13 times, 12 times, 11 times, 10. So this is 240, number of codes we can make. Right, now for the second part, the code starts with a symbol followed by 2 letters and then 2 numbers, right? Okay, so first we can say a 5-digit code, 1, 2, 3, 4, 5. So it starts with a symbol. We have 3 symbols. So the first option is, for the first digit of the code we have 3 options because it starts with a symbol followed by 2 letters. Now 2 letters, there are 5 options for the letters, and then if we use 1 letter then we have 4 options for the letters, and then 2 numbers. Numbers, we have 6 numbers. If we use 1 we are left with 5. Okay, so 3 times, 5 times, 4 times, 6 times 5. This is 1800. Okay, now for part 3, the first 2 characters are numbers and no other numbers appear in the code, right? Again, a 5-digit code, 1, 2, 3, 4, 5. The first 2 characters are numbers. We have 6 numbers. So the first 2 have numbers and the second is also a number. Right, now the rest, no other number appear in the code. So the other options are letters or symbols. So 5 letters and 3 symbols. So 5 plus 3, total 8 options. 8, 7, and then 6. Okay, so let me simplify this. 6 times, 5 times, 8 times, 7 times 6. This is 10080. Question number 4, find the values of k for which the line does not meet the curve. So if it does not meet the curve, it means the discriminant b square minus 4ac is less than 0. It's negative. Okay, first we need to find x square, put both of them equal. 5x plus 12 equals to kx plus 3. We have to find the values of k. Okay, x square plus 5x minus kx plus 12 minus 3, this is equals to 0. X square plus 5 minus k into x, and from we have 9 equals to 0, right? Now the discriminant is negative. Let me solve the discriminant. That is b square minus 4ac. So 5 minus k whole square minus 4 times the a value times the c value. This is less than 0. So 5 square is 25 minus 2 times 5 is 10k plus k square, and minus 4 times 9 is 36. This is less than 0. So we can say k square minus 10k, 25 minus 36, negative 11. Negative 11. This is less than 0. So this is a quadratic equation in k. So we have to factorize it. 1 times minus 11 we can say. So k square minus k minus 10. 1 times 11 is 11, right? So we can say plus 1 and minus 11. Okay, is minus 10. Minus 11 is less than 0. So k is common. We have k plus 1. Negative 11 is common. K plus 1 is less than 0. So k plus 1 is a factor and k minus 11 is a factor. Right, so the two possible values of k are k equals to minus 1 and k is equals to 11. Okay, so let me draw this parabola and we will check that in which quadrant interval we have the values of k. So as you can see, this is a quadratic equation and a variable k, and its k square coefficient is positive, so the opening of parabola is upward, right? And we have two roots for k, minus 1 and 11. So let's say this root is minus 1, this root is 11, right? Now we have to find when this curve is greater than less than 0. Sorry, yes, less than 0 is the lower portion. So we can say that it is less than 0 when the k value is between minus 1 and 11. Question number 5, at a point where x is equals to 1, on the curve y equals to k over 1 plus x whole square, x plus 1 whole square, the normal has a gradient of 1 by 3. Number 1, find the value of the constant k. So equation of normal has a gradient 1 by 3. So first we have to find the gradient and then do the gradient of the normal. So the gradient is the derivative of this curve, right? So the derivative of the curve is, we can say k is a constant. We do the power rule, so we do minus 2 x plus 1. The power is minus 2 minus 1. And the derivative of x plus 1 is just 1. So we can say minus 2k over x plus 1 whole cube, right? So this is the gradient, and for normal, the gradient of normal is the reciprocal, right? So we have to find at x is equals to 1. So let me do at x is equals to 1, minus 2 over 1 plus 1 is 2 cube, minus 2k over 2 cube, because x is 1, 1 plus 1 is 2 cube. So this is 2 is cancelled with this, so square, so minus k by 4, right? Okay, so for normal we have a gradient 4 by k, the reciprocal, negative reciprocal, and this is equals to 1 by 3 we have given, right? So cross multiplying we will get the k value. So k equals to k times 1, 4 times 3, this is 12. So the k value is equals to 12. Now for the second part, using your value of k, that is 12, find the equation of tangent to the curve at x is equals to 2. So the y is equals to 12 over x plus 1 whole square. For equation of tangent, x is equals to 2. So what is the y value? The y is 12 over 2 plus 1. This is 3 cube, 3 square, right? So this is 2 plus 1 is 3, yes. So 12 divides 9. This is 4 by 3. Why is this? Now the derivative we just got from the first step, dy by dx, is the derivative is this. So k is 12. So we can say 12 minus 2 over x plus 1 power is 3. So minus 24 over x plus 1 cube. At x is equals to 2, we have to find the gradient. So we have minus 24 over 2 plus 1 is 3 cube. 3 cube is 27. So minus 24 over 27. Okay, now let me write down the equation of tangent. Y is equals to m, that is minus 224 over 27x plus c. And to get the value of c, we have to use this point 2 and 4 by 3. Okay, so y is 4 by 3 equals to minus 24 over 27, x is 2 plus c, right? So let me simplify. 2 times 24 divides 27. Shifting over here, it is positive, and then plus 4 by 3. C is 28 by 9. So the C is 28 over 9. So the equation of tangent is y equals to minus 24 over 27x plus 28 over 9. This is the equation of tangent. Or we can further simplify this. 24 over 27. 24 divides 27 is 8 by 9. So y equals to minus 8 by 9x plus 28 by 9. Question number 6, part 1. Show that the left hand side equals to the right hand side. Starting from the left hand side, we can say that open the tangent, that is sine x over cos x, whole divides 1 plus 1 by cos x plus 1 plus 1 by cos x over sine x over cos x. Right. Okay, so here we have sine x over cos x, whole divides cos x plus 1 divides cos x plus cos x plus 1 over cos x, and whole divides sine x over cos x. So the same denominators are cancelled out. Cos x, cos x, cos x with cos x. Now we are left with sine x over cos x plus 1 plus cos x plus 1 over sine x. Again, taking LCM by cross multiplication. Sine times sine is sine square x plus cos x plus 1 times cos x plus 1. So cos square x, 1 square is just 1 plus 2 cos x, whole divides sine x into cos x plus 1. Sine square x plus cos square x is 1 and 1 plus 1 is 2. So we have 2 plus 2 cos x over sine x cos x plus 1. Taking 2 common from the numerator. So 2 is common, 1 plus cos x over sine x into 1 plus cos x. Cancel the like factors, 1 plus cos x. So we are just left with 2 over sine x. And that is my right hand side. 2 over sine x. Now for the second part, hence solve this equation 1 plus 3 sine x. Okay, so the answer of this equation from part 1 is 2 by sine x, and this is equals to 1 plus 3 sine x. Okay, cross multiplication, 2 equals to sine x times 1 plus 3 sine square x, or we can say that 3 sine square x plus sine x minus 2 equals to 0. Now let me factorize this. We have 3 times minus 2 is minus 6, and minus 2 minus 3 is minus 1. 3 sine square x plus 2 sine x minus 3 sine x. So we need 1. So you have minus here and plus here. Minus 2 equals to 0. Okay, sine x is common. So we have 3 sine x minus 2 plus 1 is common, 3 sine x minus 2. This is equals to 0, right? So the factors are sine x plus 1 and 3 sine x minus 2 equals to 0, right? Now let me put both the factors equals to 0. From here, sine x equals to minus 1 and x is equals to sine inverse of 1, and the other factor is we can say sine x is 2 by 3 and x is sine inverse of 2 by 3, right? This is in degrees, so this is in radians. Convert the calculator into degrees. Now sine inverse of 1 is 90, so x is equals to 90 degrees. Okay, and we know that here sine is negative, and sine is negative in the third and fourth quadrant. Let me draw this. right? We have A, S, T, and C. So in the first and second sign is positive, and third and fourth the sign is negative. So here we have theta, here we have 180 minus theta, here we do 180 plus theta, and here we do 360 minus theta. Right. So from the first factor, we know that the sign is negative. So sign is negative in third and the fourth quadrant, 180 plus 90 and 360 minus 90. We have two values for x, 180 plus 90. This is 270. And 360 minus 90 is 270. Right. Okay, now from here, what is the x value? Sine inverse 2 by 3. X is 41.8 degrees. This is positive, and sine is positive in first and second. So do 180 minus answer. This is 138.2. X is 138.2 degrees. Now let's see which values of x satisfies our domain. The domain is between 0 to 180 degree, and these values 270 and 270 does not belongs to the domain. So these are the only solutions because this satisfies a given domain. Question number 7, part A. The cubic equation, this is a cubic equation, has 3 positive integer roots. 2 of the roots are 2 and 4. Find the other root and the value of each of the integers a and b. Okay, so 2 and 4 are the roots. So when we put x equals to 2, this is equals to 0, and x is equals to 4, the equation equals to 0, right? So at x is equals to 2, we have 2 cube plus a, 2 square, plus b times 2 minus 40, this is equals to 0. So this is 8 plus 4a plus 2b minus 40 equals to 0, right? So 8 minus 40, this is equals to minus 32. So we can say 4a plus 2b is equals to 32. And dividing by 2, we have 16 here. So 2a plus b equals to 16. This is my first equation. And when we put x equals to 4 is a root at x is equals to 4, right? So just substitute x equals to 4 here. We can say 4 cube plus a times 4 square plus b times 4 minus 40, this is equals to 0. What is 4 cube? 4 cube is 64. 64. 4 square is 16a plus 4b minus 40, this is equals to 0. 64 minus 40 is 24, right? 16a plus 4b plus 24, this is equals to 0, right? So dividing by 4. So we have equation 4 times 4 is 16, 4 times 1 is 4, and 4 times 8, 6 is 24, negative 6. This is my second equation. Now let me solve for a and b. Let me rewrite the two equations. 2a plus b is equals to 16 is my first equation, and 4a plus b equals to minus 6. 4a plus b equals to negative of 6, right? So if I subtract two equations, we can get rid of b and solve for a easily. So subtract, subtract, and plus. So cancel the b, and 2 minus 4 is minus 2a, and in 16 add 6. 16 plus 6 is 22. 22. So from here a value is negative of 11, right? Now substitute the value of a in the first or second equation to get b. B equals to 16 minus 2 times of a. B equals to 16 plus 2 times 11 is 22. So 16 plus 22 is 38. So the b value is 38. Right. Now let me write down the cubic equation by substituting the values of a and b. Okay, so the cubic equation is x cube minus 11x square plus 38x minus 40. This is equals to 0, right? We have to find the third root. So let me apply the synthetic division here. And we know that 2 and 4 are the roots, right? So the coefficient of x cube is 1, x square coefficient is minus 11, x coefficient is 38, and the constant term is negative 40. 2 is the root, so let's bring 1 down. 2 times 1 is 2. Minus 11 plus 2 is negative 9. 2 times 9 is 18, minus 18. 38 take away 18 is 20. 2 times 20 is 40. We have 0, right? Okay, now further simplification. So 4 is the root. We know that 4 is the root. Okay, bring the 1 down. We know 4 times 1 is 4. And we have 4 take away 9 is minus 5. 4 times 5 is minus 20. And this is 0, right? So we can write this down as x minus 2, x minus 4, and we can say x minus 5. This is equals to 0, right? Now we can say the roots are x is equals to 2, x is equals to 4, and x is equals to 5. So these are the 3 roots of the cubic equation. Now for part B, do not use a calculator in this question. Solve the equation. This is again a cubic equation given that it has 3 integer roots, only one of which is positive. So only one root is positive, the rest of the 2 roots are negative. So it is a cubic equation. So if I substitute x equals to 1, so we have 1 cube is 1 minus 5 minus 46 minus 40. This is not equals to 0. 1 is not the root. Let me check it. Minus 1. Minus 1 cube is minus 1. Minus 1 square is 1. So minus 5. This is plus 46 and minus 40. So here we have negative 40 and negative 40 and negative 6 is 46 minus 46. This is equals to 0. Yes, minus 1 is the root. So let me apply the method of synthetic division here. We got our first root, right? So first let me write the coefficients. Okay, so the coefficient of x cube is 1, x square coefficient is minus 5, x coefficient is minus 46, and the constant term is minus 40. Okay, so minus 1 is the root. Bring the 1 down. 1 times minus 1 is minus 1. We have negative 6. 1 times 6 is 6. So in 46, take away 6 is minus 40. And 1 times 40 with a positive 40 here, we have 0, right? Now we can say that x plus 1, we have minus x plus 1. And this is a coefficient of x square. This is a coefficient of x, and this is a constant term. This is equals to 0, right? So let me factorize this. So we have x plus 1. 1 times 40 is 40. Or we can say that we need to find the factors of 40 that difference or sum must be negative 6. So 4 times 10 is 40. And 4 minus 10 is minus 6. 10x, sorry, minus 40. This is equals to 0. So x plus 1. Here x is common. X plus 4 minus 10 is common. X plus 4. This is equals to 0, right? So we have x plus 1, x plus 4, and x minus 10, right? So the 3 roots we have to find. So the 3 roots are x is equals to negative 1, x is equals to negative 4, and x is equals to 10. So only one root is positive and the rest of the 2 roots are negative. Question number 8, part 1. A particle A travels with a speed of 6.5 meter per second in the direction of minus 5i minus 12j. Find the velocity vector of A. Okay, so the velocity vector is equals to the speed or magnitude multiply by the direction divides the magnitude of direction. 5 square is 25 and 12 square is 144. So this is 6.5 over, okay, so 25 plus 144, this is 169 and square root is 13. Yes. over 13 into minus 5I minus 12j. 6.5 divides 13 is 1 by 2. So this is 1 by 2 minus 5I minus 12j. This is the velocity vector. Right, now for the second part, a particle B travels with a velocity vector 12I minus 9j. Find the speed in meter per second of the velocity of B. Okay, so the velocity vector of particle B is speed times the direction, that is 12I minus 9j, divides the magnitude. This is 144 plus 81. And this speed, this vector is also equals to 12I minus 9j. So we can say 12I minus 9j is equals to speed, the same thing we are doing here, times 12I minus 9j. Okay, 144 plus 81, hence square root of 225 is 15, divides 15. Right, so from here we can cancel the two vectors and solve for the speed. So speed equals to 15 is 15 meter per second of B. Particle A start moving with the from the point with the position vector this. At the same time, particle B start moving from the point with the position vector this. Find RA, the position vector of A after t seconds, and RB, the position vector of B after t second. So what is a position vector, right? So the position vector RA or RB is equals to the velocity vector multiplied by the position vector after the certain point, right? So we can say that the position vector of A is the velocity vector of A. Sorry, we have to times it by t. Yes, okay. So the position vector of A is the position vector of A from the point. This is 20 and negative 7, 20I minus 7j plus t times the velocity vector of A. So this is a velocity vector of A, 5 by 2 and 12 by 2 with a negative sign. So let me do negative 5 by 2 is minus 2.5I, and 2 times 6 is 12 minus 6j, right? So this is a velocity position vector of A, and position vector of B is again the position vector from the point. This is equals to minus 67I plus 11j plus t times the velocity vector of B. The velocity vector of B is, this is given 12I minus 9j. This is 12I minus 9j. Okay, we can further simplify it by combining the x, I and the j components. So here we can say that we have 20 and minus 2.5t. 20 minus 2.5t is the I component, and the j components are negative or positive. Minus 7 minus 6t is the j component. And for this, minus 67 plus 12t is the I component, and plus 11 minus 9t is the j component. So these are the position vectors of A and B. Now for the fourth part, find the time when the particles collide and the position vector of the point of collision. We need to first find the time when the particle collide. So these are the two position vectors for A and B. So the particle collides when the I component equals to I component and j component equals to j component. We will get the t value. So 20 minus 2.5 t, this is equals to minus 67 plus 12 t. Let me solve for t. So 20 plus 67, this is equals to 12t plus 2.5t, right? So 20 plus 67, this is 87, and this is equals to 12 plus 2.5, this is 14.5t. And what is the t value? 87 divides 14.5, this is 6. So t equals to 6. So the time when the particle collide is 6, and the position vector of time of collision. So we have to find the position vector as well. We can put t equals in the position vector of A, or in position vector of B. We will get the same position vector. Okay, so we can say that the position vector R is, put t over here, 20 minus 2.5 times 6. This is the I component, plus minus 7 minus 6 times 6 is the j component. Okay, so minus 2.5 times 6 plus 20, this is 5i, and 6 times 6, sorry, negative 6 times 6 and negative 7 is minus 43j. So this is a position vector of collision. Question number 9. The diagram shows the points A, B and B. The midpoint of AB is M, and the line PM is perpendicular to AB. This is perpendicular, we have given. The point P has a coordinate RS. Number 1, find the equation of line PM in the form of y equals to mx plus c, where m and c are the exact constants. So first we have to find the slope of AB and the midpoint of AB, right? So let me find the midpoint of AB. X2 plus x1 plus x2 divides 2. This is minus 3 plus 5 divides 2, and y1 plus y2 divides 2. This is 2 by 2, and this is 4 by 2. 2 by 2 is 1 and 4 by 2 is 2. So 1, 2 is the midpoint, right? Now let me find the gradient or the slope, the m value of AB. y2 minus y1, minus 1 minus 5 over x2 minus x1, 5 plus 3. This is equals to negative 6 over 8. 2 times 3 is 6, 2 times 4 is 8, right? Now let me find the equation. Y equals to mx plus c. Okay, so y equals to m is minus 3 by 4x plus c, and to solve for c we have to use a midpoint, 1 and 2. So this is 2 equals to minus 3 by 4 times 1 plus c. So 2 plus 3 by 4, this is the c value. Okay, so 2 plus 3 divides 4, 11 by 4 is the c. Sorry, I forgot to do the negative reciprocal. So the gradient of the perpendicular line is 4 by 3. Right. Right. So let me substitute over here. Y is equals to 4 by 3x plus c. Now put the midpoint. Midpoint is y is 2, x is 1. This is 4 by 3 times 1 plus c. So 2 minus 4 by 3 is the c value. Okay, so 2 minus 4 divides 3, 2 by 3. So this is the equation of line that is perpendicular to ABPM. Y equals to 4 by 3x plus 2 by 3. Right. Now for the second part, hence find an expression for S in terms of R. So as you can see, the coordinates of point P are RS, and the point P lies on the line PM. So this is the equation of line PM, right? So P lies on this line, so it satisfies the line, right? So the P coordinate is R and S. So X is R and the Y is S. So S in terms of R is S is equals to 4 by 3 R plus 2 by 3. This is S in terms of R. Now for part 3, given that the length of PM is 10 units, find the value of R and of S. So length of PM is 10 units. So means magnitude of PM. This is P is coordinates are RS, and the coordinates of M is 1, 2. Let me double check. Right, we have RS and 1, 2, right? And let me find its the length or the distance. This is x2 minus x1 whole square. So this is r minus 1 square plus s minus 2 square. this is equals to 10, right? So squaring on both sides, we can say r minus 1 square plus s minus 2 square equals to 100. Square of 10 is 100. So from the second part, we have to find r and s, right? So we have this equation s in terms of r. Let's substitute this equation to get the r value. So we have the equation of s. This is equals to 4 by 3r plus 2 by 3. Let me substitute the s and solve for r here. So r minus 1 whole square plus s is 4 by 3r plus 2 by 3 minus 2 whole square equals to 100, right? So this is r minus 1 whole square and this is 4 by 3r and 2 by 3 minus 2. Okay, 2 by 3 minus 2, this is minus 4 by 3 whole square equals to 100. Let me open the square. R minus 1 whole square is r square minus 2r plus 1 plus 4 square is 16, 3 square is 9, r square plus 16 by 9 minus 2ab. So 4 by 3 times 2 times 4 by 3. This is 32 by 9 r minus 100 equals to 0. So our terms are 1 plus 16 by 9, 25 by 9, r square, and the r are 1 and 2. These two terms for r. Minus 2 minus 32 by 9 minus 50 by 9 r, and the constant term is 1 for 16 by 9 and minus 100. So 1 minus 100 and then plus 16 by 9. This is minus 875 by 9. This is equals to 0. So let me multiply throughout the equation by 9. We have 25r square minus 50r minus 875. This is equals to 0, right? Now divide 875 by 25. Yes, we can divide throughout the equation by 25. So we have r square. 50 divides 25 is 2 minus 2 times of r. 875 divides 25 is 35 minus 35. This is equals to 0, right? Let me factorize this. So we have 1 times 35 is minus 35 and 5 times 7 is 35. We can say 5 times 7 and 5 minus 7 is minus 2. So r square plus 5r minus 7r minus 35, this is equals to 0. R is common, r plus 5 is left, minus 7 is common, r plus 5. So we have r plus 5 and r minus 7 equals to 0. We have two values of r. So r equals to minus 5 and r is equals to 7. Now corresponding to these two values, we have to solve for s. This is the equation of s. Let's substitute over here and we will get the two values of r. So s at r is equals to minus 5. This is equals to 4 by 3 minus 5 plus 2 by 3, right? So we have 4 divides 3 times minus 5 plus 2 by 3. This is negative 6. And s when r is equals to 7. So 4 by 3 times 7 plus 2 by 3, right? 4 by 3 times 7 plus 2 by 3, 10. Okay, now the values of r and s are, okay, now we have the p coordinates are rs. So r is minus 5 and minus 6. Minus 5, s is minus 6, and when 7 it is 10. Now we have to check which are the coordinates for p. Okay, so as you can see, if I draw this, okay, so here as you can see, the x coordinate is minus 3, the x coordinate is 5, right? So if I draw this axis here, x and the y axis, right? So here the x value is 5 and here the x value is -3, right? So the p value must lies between these two, right? So the r, the coordinate of r is between -3 and 5, right? So which coordinate is between -3 and 5? So is it -5 or 7? So it is 7, right? So the only coordinates of p are 7 and 10, r and s. The values of rs is, this is 7 and this is 10. Sorry, it is more than 5. As you can see, the x coordinate is -3 and the x coordinate is 5, and here we have r lies over here, right? The r is the x coordinate of p, so it is more than 5. So this is -5 and this is 7, so 7 is more than 5, so only p coordinates are 7 and 10. Question number 10, part 1. Given that y equals to ln of x over x square, find dy by dx. dy over dx is, we have to apply the quotient rule, x square derivative of ln of x minus ln of x and the derivative of x square, and the denominator function is square, x square whole square, right? So we have dy by dx, this is equals to x square, this is 1 by x, minus ln of x, its derivative is 2x, and we can whole divide it by x power 4. We can cancel this x and we can take x common from the numerator as well. So we are x1 minus 2 ln x divides x power 4. So we can cancel this with x cube. So the simplified answer is, we can say 1 minus 2 ln x over x cube for dy by dx, right? Now for the second part, find the coordinates of the stationary point on the curve, right? So the coordinates of the stationary point is a point when the gradient of the curve is equals to 0, we will get the x coordinate, and then putting into the curve we will get the y coordinate, right? So this gradient is equals to 0, 1 minus 2 ln x over x cube, this is equals to 0. So 1 minus 2 ln of x is equals to 0, or we can say 2 ln of x is equals to 1, and ln of x is equals to 1 by 2, right? And taking e power on both sides, so e power ln is just 1, so x is equals to e power 1 by 2, right? So let me find the x coordinate. So e power 1 divides 2 is 1.648, 1.65. Right, now let me solve the y coordinate by substituting into the curve. We will get y. So y is equals to ln of square root of e divides e square root whole square, right? So y equals to 1 by 2 and ln of e over, we have square and square root is cancelled, just e, ln of e is just 1, so y is equals to 1 by 2 e. Okay, so e power 1 times 2 and 1 divide answer, this is 0.1839, so y is equals to 0.184. So this is a y coordinate. So the coordinates of the stationary points are x and y, and they are 1.65 and 0.184. Number 3, using your answer to part 1, find the integration of ln of x over x cube with respect to dx. Okay, so this is answer of part 1. So let me write this, the derivative d by dx of ln x over x square, this is equals to 1 by x cube minus 2 by x cube into ln of x. Taking integration on both sides, integration d by dx of ln of x over x square with respect to dx is equals to integration of 1 by x cube with respect to dx, minus 2 is outside, integration of ln of x over x cube with respect to dx, right? We have to simplify this, right? Shifting this term on the other side. So taking this, okay, so we can say that integration ln of x over x cube dx, I just shift this term to the left and then we will divide by 2. This is equals to integration of 1 by x cube is x power minus 3 plus 1 over minus 3 plus 1 and then divided by 2 times by 2, and we have to do subtract. Dx is cancelled, derivative integration is cancelled, ln of x divides 2x square plus some constant of integration. So further simplification, we have minus 2 here, and minus 2 times 2 is 4, so minus 1 by 4x square minus ln of x over 2x square plus c. This is integration. Now for the fourth part, hence evaluate the is integral from 1 to 2. So the integration 1 to 2 ln of x x cube dx, this is these two answers, and we are not considering the constant of integration because it is a definite integral. So minus 1 by 4x square minus ln of x over 2x square from 1 to 2, right? So upper limit is 2 minus 1 by 4, 2 square is 4, minus 1 by 2, 2 square is 4, ln of 2, right? Now subtract the lower limit, minus is plus, 1 by 4, the 1 square is just 1, so plus ln of 1 over 2. Natural log of 1 is equals to 0. Let me double check. Ln of 1 is 0. Yes, so this term is equals to 0. So 1 by 16, we can say negative 1 over 4 times 4 is 16, negative ln of 2 divides 2 times 4 is 8 plus 1 by 4, right? So let me simplify this. 1 by 4 minus 1 by 16, 3 by 16. So this is 3 by 16 minus ln of 2 by 8. You can keep it as it is or you can convert it into decimals. Both are okay. Question number 11. Do not use a calculator in this question. Solve the quadratic equation giving your answer in the form of a plus b square root of 5 where a and b are constants. Okay, quadratic formula, we have to apply x is equals to negative b, this is 3, plus minus square root b square minus 4 times the a value square root of 5 minus 3 plus minus 3 times the c value square root of 5 plus 3 whole square root divides 2 times of the a value square root of 5 minus 3. Okay, so here x is equals to minus 3 plus minus square root 3 square is 9 minus 4, this is square root of 5 square, this is 5 minus 3 square is 9 divides 2 square root of 5 minus 3. So from here minus 3 plus minus square root 9 minus 4 times 9 take away 5, 6, 7, 8, 9, negative 4 divides 2 times square root of 5 minus 3, right? X is equals to minus 3 plus minus square root 9, negative times negative is positive, 4 times 4 is 16, divides 2 square root of 5 minus 3, 16 plus 9, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So it is 25. So square root of 25 is just 5. So minus 3 plus minus 5 divides 2 square root of 5 minus 3. So these are the roots. Now let me find the two roots with a positive and with a negative, right? Now the first one is x is equals to minus 3 plus 5 divides 2 square root of 5 minus 3. So minus 3 plus 5 is 2, and 2 divides 2 is just 1. So x is equals to 1 by square root of 5 minus 3. Now we have to rationalize with the conjugate of the denominator. So square root of 5 plus 3 divides square root of 5 plus 3. So from here x is equals to square root of 5 plus 3 divides square root of 5 square is just 5, and minus 3 square is 9, and 5 minus 9 is sorry, this is 5, not 25, and 5 subtract 9 is minus 4. So x is equals to minus 1 by 4, 3 plus square root of 5. We have to find the answer in the form of a plus b square root of 5. So we can say that x is equals to a value is minus 3 by 4, and b value is minus 1 by 4 square root of 5, right? Now let me work on the second root. Okay, now the second root is x is equals to minus 3 minus 5 divides to square root of 5 minus 3. So 5 and minus 3 is negative 8. So this is minus 8 by 2 square root of 5 minus 3. So 2 times 4 is 8. So x is equals to minus 4 divides square root of 5 minus 3 times square root of 5 plus 3 divides square root of 5 plus 3. X is equals to minus 4 times square root of 5 plus 3 divides, again we have square root of 5 times square root of 5 is just 5, minus 3 square is 9, so we have negative 4. So x is equals to minus 4 square root of 5 plus 3 divides negative 4, right? We can cancel the negative 4 with the negative 4, so x is equals to 3 plus square root of 5 in the form of a plus b square root of 5. So these are the two solutions, and a and b are the constants. So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.